So question number 6 on 2016 is another short response. Let's take a look at the whole problem. It is an equilibrium problem. We can tell that right away because you can see that double arrow up here, okay? But they're saying that the polyatomic ion is commonly abbreviated by EDTA, and the ion can form complexes with metal ions in aqueous solutions. So if I've a complex of the EDTA with a barium ion is formed according to this equation above. So I'm starting with a certain amount of both reactants. I've got 50 milliliters of a solution of EDTA that has 0.3 molars, and I've got a 50 milliliter of a 0.2 barium nitrate solution to produce 100 milliliters. Keep in mind, this is my net ionic reaction, okay? So all of the barium is going to, for that reaction, is going to come from barium nitrate. That is your spectator ion. So it is not involved in the chemical reaction at all. It's going to start in solution, stay in solution. It's not going to form any complex ions. So this problem is they want to have you evaluate the K, and this K is really a whether or not, how much of that complex ion is formed. They want you to justify your answer. So if you are justifying your answer, you are going to have to show some calculations. And part B is now we're changing the solution by diluting it down. After equilibrium is reestablished, is the number of moles present greater than, less than, or equal to in the present solution. Justify your answer. So that is really sort of that claim, reasoning, and evidence type of problem. So let's look at part A first. Okay, so part A, question part A is they want you to consider the value of K. So they want us to look at our equilibrium constant and determine the concentration. So the question is asking, determine the concentration of our product in 100 mLs of the solution. They want you to justify your answer. So we need to show some sort of calculations here. Let's take a look at our two reactants. All of my barium ions are coming from that barium nitrate, which is a 0.2 molar, 0.20 molar solution, and I've got 0.05 liters of that. Okay, and then the EDTA 4- is coming from a 0.30 molar solution. I've got the same volume of that solution. If you look at this value and you look at the exponent, that is a really big value, which means that it's going to go mostly to completion. There's going to be very little of our reactants left. All right. If I look at my two reactants, same volume, this is a lower concentration. And my reactants here, it's a 1-to-1 ratio to form that complex ion. So this is going to be my limiting reactant. This is going to control how much of my product is made at the end. Okay, so that is my limiting reactant. That's going to control how much of the barium, the complex ion, is formed. So let's take a look. I'm starting with 0.20 molar, but what I'm going to be doing is my volume is going to increase by a factor of 2. So if my volume is going to increase by a factor of 2, the concentration, so the concentration of my barium ions is going to go down by half. Okay, it's going to go down by, by a factor of 2. Okay, so because I'm doubling my volume. So if I'm doubling my volume, my concentration is going to go down by 2. So since that's controlling how much product is made, the concentration of my complex ion is going to be the concentration that I start off with, and it's going to go down by half. So the concentration is going to be 0.10 molar. Okay, and that gives you a justification of that answer. This last part of the problem, they're asking if you dilute the solution to a total volume of 1 liter. So in other words, we would have had 0.1 liters, and now we are going to 1 liter. So we're diluting it down by a factor of 10. So let's just keep that in mind. After equilibrium has been reestablished, so when you hear this, after equilibrium has been reestablished, we're talking about Le Chatelier. They want to know, is the number of moles of barium present in the solution greater than, less than, or equal to the number of moles of barium present in the original solution. They're also asking for a justification of your answer. So we are going to have to show some sort of math justification here. So let's start by writing our equilibrium expression. If I were to write my equilibrium expression, here's my product. They're all aqueous solutions, so everything's going to be included in the expression. Oops. Over my barium ions and my EDT. Okay, and it's equal to this particular K value, which is quite large. So what we're going to have to do is we're going to have to compare how does Q compare to K. So we've established equilibrium. Now we're going to go ahead and change our situation. So, and when we change our concentrations, everything, the concentration of all of these is going to go, since we're going from 0.1 to 1, it's being diluted down by a factor of 10. So the concentrations are all going to be multiplied by 1/10. So if we do this, everything is going to be diluted down by a factor of 10. So that's 1/10, that's 1/10. And whoops. That's going to be 1/10. Okay, so everything that was there before was my K value. That should be a minus. Okay, so I'm actually ending up with, those are going to cancel out. This is 1 over 10. So Q is going to be equal to 10 times the K value. So Q is going to be, so here, if here's my K, my Q is going to be much bigger than my K value. So if my Q is going to be much greater than my K value, I'm going to shift to get back to equilibrium. So if I am shifting in this direction, this concentration is going to go down, the concentration of my reactants is going to go up. This is going to be greater than the number of moles present in the original solution, because I'm going to have to make a shift to reestablish equilibrium. And that takes us to the end of problem 6 in 2016.